Orbital Gardens, this is Mission Control. We are confirming acquisition of your signal. You are live in 5, 4, 3, 2.
Hello and welcome to Gardeners of the Galaxy, the podcast for all of the sentient beings in the universe who have a passion for plants. I am Emma the Space Gardener and I will be your host as we explore gardening on Earth and beyond. It's Gardeners of the Galaxy's 4th birthday. To celebrate this auspicious event, I looked up what would be a suitable 4th anniversary gift. Traditionally, there are two that would fit the bill: fruit and flowers. So Ryan and I have baked a lemon cake with strawberry frosting and sugar flower decorations, and I have picked two fun stories from the astrobotany archives to share with you. We'll get to that in a moment, but first I'd like to say a big thank you to everyone who has supported the show with thoughtful guest appearances, generous financial donations and kindly word-of-mouth recommendations. The show wouldn't still exist without you, and I am very grateful. There are many ways to support the show, and if you'd like to be part of the Gardeners of the Galaxy community, you can find out more at theunconventionalgardener.com/boosters. Okay, so the cake is ready, the guests are here. I'm wearing my new Gardeners of the Galaxy t-shirt, and it's party time, so let's light this candle. For last year's birthday episode, I told a trio of stories about trees in space. The tree seeds exchanged during the Apollo-Soyuz test project, the dwarf lemon tree that lived on Mir, and the Canadian willow saplings that grew on the International Space Station. This year, I'm going to talk about a tree that's bred for space, but hasn't been there yet. It's not that we haven't grown any fruit in space. We have, at least botanically speaking. There have been peas and soybeans, the wondrous chilies of PH04, and, of course, the occasional tomato. But when people say fruit, they mean an apple or a banana, or maybe even some dates. The problem is that those things grow on trees, or, in the case of bananas, large herbaceous flowering plants, and the one thing that spacecraft are truly lacking is space. The plants themselves take a long time to grow to fruiting age, and then they generally flower and fruit just once a year, and some of them have quite specific climate needs, such as a long period of winter chill. A year ago, Lucas van der Zee at Wageningen University was working on producing cultured fruit, i.e. growing fruits in his fermentation-style tanks instead of on trees. Since then, he has also made crepes with cellular wheat, so that's one possible solution. The US Department of Agriculture is working with NASA on another. At the USDA's Agricultural Research Service, plant molecular biologist Chris Dardick and his team have been investigating whether the key lies with the tomato, a plant that can continually flower and produce fruit. They have genetically engineered plum trees to overexpress a key flowering regulator gene that causes them to flower all the time and eliminates the need for cold dormancy. They were able to make the trees flower and fruit within 1 to 10 months, compared to the 3 to 7 years that's normal for typical plum trees. That would be a very useful trait to have in a space fruit tree, but it will also have benefits on Earth, allowing increased fruit production in indoor or urban farms to feed local residents. After all, a 2018 study showed that the world does not currently produce enough fruits and vegetables to enable everyone to eat a healthy diet. In fact, one of the reasons researchers develop these fast fruits is to greatly accelerate the breeding cycle so that they can develop disease-resistant cultivars in a fraction of the time it would normally take. So that could put us one step ahead of pests and pathogens such as the plum pox virus. As well as flowering and fruiting much more quickly, the new plum trees have other traits that could make them more suitable for space gardening. The altered gene seems to disrupt apical dominance, meaning the plants tend to grow bushy rather than tall. A moderate amount of pruning could keep them to the size of, say, a sweet pepper. This smaller growth habit also reduces the amount of wood produced, which means a lower amount of inedible biomass and a higher harvest index. And there have been unrelated studies which show that phytochemicals found in plums could help to prevent, or maybe even reverse, bone loss resulting from exposure to radiation. Tests at NASA Kennedy Space Center compared the performance of several of the plum genotypes. Raymond Wheeler, Joy Amasa and Gary Stutt then studied the 4 best performers, known as NASA 5, 6, 10 and 11, which they expected to be compatible with the size constraints of plant growth hardware on the International Space Station, such as veggie. Their experiment aimed to study the growth and productivity of the dwarf plums in controlled environments under the same environmental conditions found on the ISS: light, temperature, relative humidity and CO2 levels. The plan was to establish dwarf plum trees in controlled environment growth chambers and monitor a range of growth and horticultural parameters using flight constraints, growing volumes, environmental conditions, watering techniques and electric lighting. They could then establish the feasibility of growth protocols and cultivar selection for spaceflight. They explored growing the plants in commercial potting mixes with a liquid fertiliser. Many plants proved to be sensitive to water levels in the soil, reacting poorly to overly dry or wet conditions. They tried to improve cloning techniques using branch cuttings and monitored leaf transpiration and stomatal conductance rates at 2 CO2 concentrations. They found that reliable fruit development required cross-pollination using wild-type pollen, with NASA 5 and NASA 11 the most reliable varieties for pollination and fruit set. Based on the horticultural challenges and the need for cross-pollination, the research team recommended further testing and more breeding work before the plum varieties can be considered for a space flight. So it looks like it will be a while still before we can plant a little plum tree in the orbital garden. Okay, so that was the fruit. Now for the flowers. We've all seen zinnias growing on the International Space Station, but the story I keep coming back to didn't come to pass, and that is Bernard Fong's plan to grow tulips on the moon. Professor Fong is a French scientist at the European Space Agency. In 2005, he was project scientist for SMART-1, a spacecraft mapping the lunar surface topography and mineralogy, with the hope that this information would lead to new insights about the moon's evolution. He was also pondering the steps needed to establish human bases on the lunar surface, and whether the challenges of living there could be eased by something as beautiful and delicate as a flower. He thought the surface of the moon might be a good place to try and turn a desert into an oasis, starting inside an artificial biosphere. He believed that it is important to learn how to develop life on the moon. Fong was part of a team that came up with a concept for a small lunar ecosystem, the first extraterrestrial man-made ecosystem, or FEM, and he was working with botanical groups in the Ukraine and the Netherlands looking at very resistant plant forms. Living in the Netherlands, Fong crossed a tulip field on his way to work, so it's perhaps natural that his thoughts turned to tulips. You can freeze a bulb, he said. You can sterilise it. You can transfer it to the moon, and then, with sufficient water, some heat, and an artificial CO2 atmosphere, you could see the flower grow. He had colleagues developing miniature cameras and envisaged watching the tulips grow day by day. The camera could be set to show Earth in the background, he thought. Researchers at the Ukrainian Academy of Sciences in Kyiv had just demonstrated that marigolds planted in simulated lunar regolith grew better in the presence of bacteria that could extract nutrients from the rock. Fong felt that, as tulips need little in the way of fertiliser, they could form the basis of a precursor lunar ecosystem, housed in an enclosed artificial atmosphere with algae and bacterially enhanced lunar soil. Not only would the flowers be a sophisticated life science experiment, but they would help provide psychological comfort to the astronauts. Seeing plants grow could make them happy because they would see life developing in the lunar desert. The moon tulip was just one example of the futuristic, fun and possibly even feasible ideas dreamt up in Professor Fong's think tanks at ESA's European Space Research and Technology Centre, ESTEC, in the Netherlands. He presented the ideas at the European Geosciences Union meeting in Vienna and was putting forward a proposal for a mission called Moon Next, using a roving vehicle in around 2015, or a subsequent lunar logistics lander in 2016 or 2017. Although we may never see Professor Fong's tulips growing on the moon, Artemis 3 is currently scheduled for 2026 and will take LEAF, Lunar Effects on Agricultural Flora, to the moon. LEAF is a scientific endeavour involving red and green brassicas, duckweed and Arabidopsis, but it's not likely that any of those will have time to flower. Still, Interstellar Lab has a plan to grow roses on the moon. The company's Little Prince project involves a SpaceX Starship launch, Astrolab's Flex rover, and a miniature version of an Interstellar Lab biopod. And that could all happen, they say, as soon as mid-2026. That's it for this episode, so I will hand you back to Mission Control. Capcom, I'm not sure about a fruit tree experiment. I don't want to end up with a damson in distress. What do you think?
Orbital Gardens, this is Mission Control. confirming termination of your signal. The higher-ups are recommending you try a fruit experiment next. They know you're nervous, but they think you should grow a pear. Mission control out.